This is a problem in your book on page 52, number 39. It was not a homework problem, but I thought it was a good problem, so I'm going to do it for y'all that want to watch a video that might help you on the test. This is another two-part problem. You can tell it is when you read it. You just have to break it into two parts. A car starts from rest and travels 5 seconds with a uniform acceleration of positive 1.5 meters per second squared. The driver then applies the brakes, causing uniform acceleration of negative 2.0 meters per second squared. If the brakes are applied for 3 seconds, A, how fast is the car going at the end of the braking period, and B, how far has the car gone? So we got two parts here. We got a part where it's speeding up in this direction. So it's got a velocity this direction. It's got an acceleration in this direction. Acceleration, velocity, same direction, speeds up. Starting somewhere in here, there's a part 2. And that's where it has a larger velocity by the time it gets there going this way. But now it has an acceleration in the opposite direction because he's braking. So slowing down. So what we need to do is we need to figure out for part 1 what the final velocity is right here, knowing the initial velocity was 0. And to do that, we can use the first equation, I think, v equals v naught plus at plus, and so it's v equals 0 plus positive 1.5 meters per second squared times 5 seconds. And I get a final velocity of 7.5 meters per second. Now, that's part 1, final velocity. But for part 2, the final velocity for part 1 becomes the initial velocity for part 2. And that is 7.5 meters per second, because that's how fast it's going right here when it starts putting on the brakes. So, it puts on the brakes for 3 seconds. Acceleration is negative, so now we know time is 3 seconds. Acceleration is now a negative 2 meters per second squared. And we want to know how fast it's going at the end of the braking period. Well, so let me do this in a different color. So I already had a different color. So I can make a line here, and everything below this line is part 2. So v equals v naught plus at. So this is the answer to A. This is A. Notice we had to do a part up here for part 1 before we could get to the answer in part 2, where he started braking. Speeding up part 1, braking part 2. So the final velocity after braking is going to be 7. So it started out at 7 meters per second minus 2 meters per second squared times 3 seconds. So 3, that's supposed to be a second. It looks like a 5. It's kind of hard to write with this thing. You have to look. You're looking at the screen, but you're not looking at your hand. So this is a 3 seconds. All right. So if you do that, you're going to get 7.5, basically minus 6. You're going to get 1.5 meters per second after he brakes for 3 seconds. All right. So then it says, how far has the car gone? How far? I'll do that in a different color too. So, so to do that, I'm going to have to do 2 things. I'm going to have to find how far he went in part 1, how far he went in part 2. And then I'll add them together. So to do that, I'm just going to do this. Extend the page a little bit. So x equals x naught plus v naught t plus 1/2 at squared. This is going to be for part 1. So x for part 1, we'll call this 1, starts at 0, has an initial velocity of 0, so this whole thing right here is going to be 0 right there, plus 1/2 times 1.5 meters per second squared times 5 seconds. Square that. When you do that, you're going to get 18.75. So x1 equals 18.75 meters. We'll round off at the end a couple of 37 meters or something. x2, let's do that in red, I get red. x2 is going to equal, what is, we could say x naught is 18.75, which it is, so let's just do that. That's how we add them together anyway. We have to add them together, so x naught, this right here, is now 18.75, because that's where it's located when he starts braking. Plus, he's now moving at 7.5 meters per second, times 3 seconds, minus 1/2, out of room here, 2, that's meters per second squared. I'll skip that part so I can fit it all in. 3 seconds, I'm going to square that. This minus is here because that's a -2 meters per second squared. If you do the math all the way across, you get the final total distance as 32.3 meters. So that's B. That's how far this van or this person, this car traveled while first part accelerating, second part braking. Matter of fact, if we looked at a graph, if I could do a graph here, well, I can just draw it. If I look at a graph, then really for the first part, this is we could look at position time, or velocity time's easier because it won't be a curve, it'll be a straight line. And remember, the slope is the acceleration, so this slope would be positive 1.5, and then so that's speeding up, and then he starts braking. This is all positive velocity. Positive velocity's here, negative velocity here. No backwards till he gets below. This is 0. No stopping unless it hits the x-axis like it started, and no go backwards unless it goes down below. So this V does not mean turn around, it just means slowing down. It's going to be steeper. Okay, hold on, let me erase that. It's going to be steeper than 1.5. It's going to be 2. It's going to be steeper. So, we'll just guess, all right? That's probably not 2. But he's going to end up down here somewhere. So, total distance is going to be 32.3. Anyway, hope that helps. That's just an extra one if you want to look at it.